Welcome to the TechArena, featuring authentic discussions between tech's leading innovators and our host, Allyson Klein. Now, let's step into the arena.
Welcome to the Tech Arena. My name's Allyson Klein, and today I'm really delighted to have Josh Patterson, CEO and co-founder of Voltron Data with me. Josh, it's a real pleasure. Welcome to the program.
Thanks, Allyson.
So you guys are delivering really interesting solutions to the market, and I was so excited to hear that you were going to come on. Why don't you just start with an introduction of Voltron and your background as the co-founder of the company?
Well, to start, Voltron Data, we formed the company to really push enterprise data solutions to new bounds. One of the things that we saw coming in the market for a while now is compute systems weren't really keeping up with downstream AI, machine learning, geospatial, graph analytics systems. Really, all the tools that allow you to derive more insights from your data or make more business relevant decisions faster were getting faster, running at a much larger scale. And the data pipelines, ETL, feature engineering, were really holding things back. And so Voltron Data, we wanted to address this in two ways. One was through open source and open standards primarily, really allowing people to build on open standards without the risk of things just purely being open source. When you provide enterprise support for open source software, specifically software that's meant to be used across language boundaries, system boundaries, compute boundaries, you really want to make sure that people know that it's reliable, that there are hot fixes to security vulnerabilities, the ecosystem is staying as up to date as possible. And so that's what we've been doing for the first 2 years of our company. We'll continue to do that. And we're really proud of all the work that we've been doing across the open source ecosystem, really allowing more efficient data movement, data processing, and bringing all these disparate frameworks and capabilities together more graciously.
Mm-hmm.
The second part of what our company does is around acceleration, making, compute faster, essentially. This really kind of goes well with my work that I did at NVIDIA. Several of us were heavily involved with Rapids. And so Rapids is a GPU accelerated collection of libraries that allow you to do data frame processing, machine learning, graph analytics, all these different things on NVIDIA GPUs. But Rapids in and of itself was a little bit difficult to use. And it was held back by a lot of the existing frameworks, at the time, Spark, Dask, and other distributed compute engines were really designed from the ground up for CPUs. And because of that, they weren't accelerator native. They didn't take advantage of all the different acceleration possible graciously. And we thought that, we could build a system that could fully leverage acceleration and all the open standards that we've been working on and championing to really provide a state-of-the-art compute experience to really keep up with the demands of machine learning, deep learning, and all these other types of systems. And that's Theseus. And so we recently just went to market with Theseus. We launched in Barcelona a couple of weeks ago with HP at HP Discover. And we're really excited about it. It's a distributed compute engine that, fully utilizes NVIDIA GPUs, high-end networking, storage. It also utilizes vectorized computing on x86 and ARM. But the main thing is it reduces the time to doing feature engineering as well as reducing the footprint. Doing what would take hundreds of servers in a much, much smaller footprint, saving costs, doing it faster, and just, more energy efficient.
You really took the industry by storm with this Theseus announcement, and it got a lot of attention from folks. I think you opened some eyes about what you were capable of doing. One thing that I wanted to ask you about, I know that you've talked to a lot of customers about what they're trying to do, and you've talked about this performance wall. Can you talk about what you mean by that and why Theseus is such an important part of the solution of climbing that wall, if you will?
Absolutely. one of the things that we've noticed is people want things faster. Uh, with ChatGPT, uh, if a response took 2, 3 minutes, it really wouldn't be a conversation with data.
Right.
And so what makes these things really powerful is you get responses back in, a second or two. And, I remember a time when, doing linear regressions or logistic regressions took a decent amount of time. You can now train really complex models, in seconds. There's a time when running XGBoost at a couple terabytes would take, hours of training time, um, and now that's seconds. And so the whole industry has really pushed how fast we can do machine learning. And that's, really not even talking about, really advanced AI. And so the training times, of machine learning, deep learning have accelerated so much. What we're seeing is people are spending less than 20, 30% of their time actually doing training. Most of their time is spent doing pre-processing, feature engineering, getting the data into the format where you can train a model. And that's taking significantly longer now than ever before. And the problem is only getting worse. Um, Roughly every time a server gets 5 times faster at doing training or inference, is requiring almost 50 times the amount of ETL uh, compute footprint to keep up with that same speed.
Hmm.
And that's just getting, really difficult to manage. If you have, terabytes of data and you're using Spark and all of a sudden, you're like, hey, this is great, but I need this to happen 2 times faster, 3 times faster. It's not that you need 2 to 3 times more servers. Sometimes you might need 5 to 10 times more servers.
Right.
And it's just really starting to grow, exponentially. And it's this kind of asymptotic problem. Eventually, it's as fast as it's going to be. If you have a finite amount of data and you want it faster, there's just this barrier to doing it any faster. And that's the wall. And what we've seen with this is there are a lot of companies where they're like, if I could just do ETL and feature engineering faster, if I could bring all of my data together from different data silos, amalgamate it in a certain way, and then feed it into these models for either training or inference or graph analytics or geospatial
Hmm.
intelligence, I could derive real value. And it's not even the cost of how much it would cost. It's we can't build another data center. We can't, really scale this to any larger of a cluster because it's just prohibitively expensive or we're just out of room. Um, and so how do we shrink that footprint back down? How do we push those SLAs to, new levels? Um, and that's where accelerators come in, using all the same underlying technology that is made, graph and geospatial and AI and ML so fast. We use that for uh, ETL, feature engineering. We can get, significantly faster results. Um, but it's hard.
Hmm.
It takes a lot of work. And, we really couldn't get there without a lot of the open standards that we, kind of depend on, Apache Arrow, Substrate, IBIS. And so what we've done is we've, really kind of took a holistic approach of what's slowing down these systems and systematically removed a lot of these barriers so we can get over the wall or get around the wall or break through the wall, however you want to say it. But we just have to be able to, really accelerate this data munging.
That makes a lot of sense. When you think about open source, and you talked about the importance of open source, when you talk to customers, why is that so critical for them?
Open source is really important for two reasons. One, it accelerates innovation. You never know, um, what's coming next, and being to kind of take, an idea and extend it further, or integrate into a new solution allows people to kind of quickly iterate on new ideas. And open source isn't just about code being free; it's about kind of sharing what's possible as quickly as possible so we can, really kind of continue to diversify ideas. And so if how you connect systems together, how you build systems, if all the foundations were closed source, you're constantly repeating the exact same thing. There's a lot of redundancy. and just kind of dead weight loss of engineering.
Hmm.
And open source really ameliorates that. Arrow is a really great example of this because it standardizes how data is represented across different languages and hardware. And even something that simple on paper is actually a really hard, pretty large library to build and maintain, but it's extremely powerful. If I don't have to copy and convert data when I'm going from a Java application to a Python application, if I don't have to, convert data into a new format when I'm going from CPU to GPU, I free up so much, system resources. And then when you start doing this at scale, it's really powerful. It really starts to allow pipelines to be much, bigger, faster, more resilient. Um, and open source allows people to really do these things, in a more nimble and novel way. And that's just kind of the open standard side.
Hmm.
The other side of this is, systems like PyTorch. PyTorch allows people to really, create new deep learning frameworks, models. It allows people these gracious on ramps for when they want to bring, new innovation to market. There's, hey, if you build it with this framework, people can use it quickly. They can integrate it with some of their existing code. Uh, it just allows, people to really kind of iterate faster on ideas without having to start over from the ground up or wait for a specific vendor, to release something new. And so open source really is about accelerating ideas and reducing a lot of waste.
Hmm. That makes a lot of sense. One of the things that you announced that I thought was really interesting, especially given your background in GPU, is that Theseus supports a number of different architectures from a processor standpoint, CPU from an x86 standpoint, ARM processors, and GPUs. And you also said even more accelerators in the future. Why did you make that decision to be so broad in terms of your support? And where do you think customers are going with their deployments of different architectures and heterogeneity? Excuse me.
The reason why we went so broad is the fact that there's still a lot of, x86 and ARM hardware available to users. And there are times where you want to use whatever computing resource you have available just to get the job done. There's a scarcity of NVIDIA GPUs. Everyone is talking about how hard they are, to acquire. The lead times are pretty long, and we didn't want to limit people with how they were doing ETL and feature engineering. Part of this is we really wanted to improve people's experiences, really regardless of what infrastructure they had today. Now, it is faster, it is cheaper, it's a smaller footprint. Using NVIDIA GPUs, high-end networking like InfiniBand or Rocky, and the performance numbers are extremely impressive with NVIDIA GPUs. But we should still be able to run these systems on x86 and ARM because there's a lot of spot pricing with ARM in particular that's extremely cost effective. There's a lot of innovation happening in the ARM space where ARM is having really large memory systems, really, really high core count, and it's just really adding a lot of value to customers to be able to write code and target, really a lot of different underlying systems. When we talk about, and more hardware to come, there's a lot of innovation up and down the stack. It's not just in the compute, as we think about it today, but it's also in networking. We want to support, an increasing number of, networking backends and in storage, Substrate, this kind of data analytics intermediate representation layer, data analytics IR for short, allows us to map logic to different engines without having to, necessarily rewrite code for an engine. That engine, we typically think about that as like, a compute engine, x86, ARM, NVIDIA GPUs, but that compute engine could be, computational storage. It could be, filtering and doing projections at the lowest level where the data is residing at rest. And so, we built the system to take advantage of all the acceleration we have today. But there are many people working on computational storage right now.
Hmm.
Wouldn't it be great is, when these, storage systems go to market, there's an engine out there that could immediately, leverage, those computational storage systems. It had, high quality integration, and, through open standards, it knew how to interact with them, very graciously. And so not only did we want Theseus to be really good at, what's in the market and available today, but what's going to be in the market, soon. And I do think that, computational storage, is kind of the next frontier of data analytics. It's not just accelerating kind of your in-memory computation. It's not just graciously falling between, accelerated memory to system memory to disk, but it's also is pushing, computation to the storage devices. Um, and, eventually, the networking devices as well, being able to do, smarter, compression and decompression, as data is in transit.
Yep, that makes a lot of sense. Now, you announced this with HPE, and they said that they're going to fold it into their data lake. I'm sure others will follow. What have you been hearing from customers more broadly about the Theseus launch, and why is it so important to have partners like HPE at your side?
People are excited. So that's great. One of the things that, when we were still in, quasi stealth, people are always asked, well, is it a SaaS? Is this going to be our next database? Is this going to be our next, data lake house, data warehouse? One of the things that we address, I think fairly well, hopefully well, was partnering with HPE that, we're not trying to be a database. We're not trying to be a data lake. I've said this a lot, data has gravity, but people still need really great, computational systems. They need accelerated systems. They need to be able to do more with their data with, less hardware, less footprint. And this is why partnering is, really important to us. HPE, Esmeralda Unified Analytics, and GreenLake, their hybrid cloud SaaS platform, they have really large users. They have their own data fabric. It's just a very well established company, and their software growth is, phenomenal. And so now taking, all this innovation in hybrid cloud and, their ability to allow users to spin up different engines, whether it's Trino or Spark, was already kind of pushing the bounds on, composability and how we think about systems of the future. It's not, one size fits all. There's no silver bullet. And so the partnership with HPE just felt really natural because, they already had the system that allowed users a lot more freedom to do what they wanted to do with their data, use the engines that they want. And so introducing another engine, ways to interact with different engines through, IBIS, this kind of unified Python front end, it just felt natural. It worked, but it really, solidified to our customers that we're not trying to change how you do things. In fact, we want you to own your code. We want that code to be as widely deployable as possible. We just wanted to be able to target, accelerated systems as well. And a lot of customers are really happy about that. Too often people want to kind of lure you into their new state of the art, really fast system and then lock you in, build walls that kind of keep you as their customer. And, we really wanted to build rampant bridges. People, want to write code and target some other system than ours and then target, Theseus for certain use cases. That's completely fine. We're very happy with what's happening in the single node space. Like DuckDB, for instance, it's an amazing single node engine. It's extremely fast. And if you have a problem that's a terabyte or smaller, there are enough, ARM servers and x86 servers with terabytes of system memory. Just use DuckDB.
Yep.
It's a really great tool for a lot of, problems, not even small scale, fairly large, data problems. And how cool is it that you can, write code and run it on your laptop for, really small scale problems, scale to these, really large fat nodes, and, do computation there. And then, also run that on distributed GPUs. And customers really were just like, thank you.
Yeah.
That's refreshing. very different. People, I think, really expected us to build a SaaS. And, we would tell people we're not building a SaaS. And they're like, oh, yeah, sure. We're going to wait for, whenever you launch your SaaS. And the launch really reiterated that, we're focused on building open standards to allow people to have more options, to be more efficient, to build better systems, but not to be as prescriptive of what those systems have to be.
Mm-hmm. That makes a lot of sense. We're headed into 2024. I think this time last year, we were just starting to hear about ChatGPT and what that would change in 2023 around AI and the acceleration of AI and generative AI. As you look forward and you're talking with other folks in the industry, you obviously have, your finger on the pulse of what people are thinking about in terms of data pipelines and what they're trying to do with them. What do you think we're going to be talking about next year? And where do you think Voltron fits into that broader conversation?
I do think that open standards is going to be the kind of the next evolution of open source. Not just open source and, hey, this is open source, but, we changed how, X, Y, and Z work. I think people are really going to start to lean into open standards a lot more. Hey, this system is great, but why can't it, also, run code that was written for this other system? Modularity, interoperability, composability, extensibility. I think those 4 words are going to become much more common in enterprises. Why does this system, not allow me to bring this type of data or API, to it? And I think people are going to start to, really request that, more systems start to adopt these open standards, arrow in, arrow out, talking with, kind of these universal front ends like IBIS. And we're already starting to see that. And so I think that's going to be, one trend in 2024. It's going to remain strong. I think the other one is acceleration. We've lived this world of too long of just scale out, just throw more hardware at it. I think performance is finally coming, back into relevance. People are excited about performance again because, costs matter. And, with all the different things going on around the globe economically, people are, you just can't just spin up, thousands of nodes and just, have these long running overnight jobs. People want things to happen faster and more efficiently. And so I think, we're going to start to see a lot more focus on the intersection of HPC and data analytics. I think, kind of those two worlds had started to grow apart, but they're going to come back together in 2024. And one area in particular that I'm excited about is computational storage. I think, we're going to see a lot of computational storage startups, a lot of, existing storage players really start to push the bounds of computational storage, and hopefully open standards and kind of computational storage will, kind of see eye to eye early on. So maybe we will have a few less of the mistakes, that we saw in the big data space where you had competing standards happening.
That's fantastic. I've learned a lot in this interview. Thanks for being on the show. I can't wait to hear more from you and your team. And I'm sure that listeners online are also intrigued by Theseus and what you're delivering to the marketplace. Where would you suggest folks find out more and talk to your team about an evaluation?
Absolutely. VoltronData.com, our website. I think it's, one click away to learn more about Theseus, get a demo. We're excited to really work with large scale enterprises to address, their data challenges and, hopefully be able to kind of accelerate their data systems, as well as, we'll have some new joint marketing with HPE in early 2024. But right now, the Voltron Data webpage, very soon, if there's any kind of issues that people are having with any of our open source products that we support, like Arrow or IBIS or Parquet, drop us a line. We're happy to have our team, talk with them, evaluate, and see how we can help.
Awesome. Josh, thank you so much for being on the program today. It was really fun.
Thank you, Allyson.
Thanks for joining the Tech Arena. Subscribe and engage at our website, thetecharena.net. All content is copyright by the Tech Arena.